Okay, so in this video, we will be covering question 3, which is compute mean, median, mode, and standard deviation for a given small dataset. Explain when each measure is appropriate. Okay, so let's see. We are discussing mean, median, mode, where we have taken this small dataset with 8 values. Let's find the mean, which is sum of all observation in upon number of observation. We take the sum upon number of observation, then which is 8, which is 5.2, right? Then we calculate median, which is the middle value. When we check for middle value, we find that the number of records are even. So we take fourth and fifth value and take its average, which comes out to be 4.53. Then mode is the most frequent value. As you can see, 4 is appearing 3 times and 5 is appearing 2 times. So mode will be 4, right? Then let's see standard deviation. That standard deviation means how much different the data is from mean. So we find mean as 5. So for all dataset item, let me see. Yeah, these are the dataset item. For all dataset item, we subtract it for mean and square it, and then we add them up. That this gives us value as 32. So this is our standard deviation. Now let's see when to use what. So basically mean is used for imputation or basically for symmetric data where there are no outliers. For example, exam scores. Then median is used for skewed data or with extreme data outliers. It is more robust to outliers, right? Mode is used for imputation with categorical data or discrete data to find the most common category. And standard deviation is used to find pattern in the data to check if the data set is normally distributed or not, right? Right. Here we assume data is around roughly base shape pattern, and when mean is useful, that the spread should be meaningful, right? Now let's see the B part. What is the difference between error and artifacts in data cleaning? Explaining two imputation techniques. So let's see what are errors and what are artifacts. Errors versus artifacts, right? Errors are the information lost during the data acquisition. For example, when we are collecting data, power failure, sensor malfunction, writing impossible values of these are often irrecoverable. We can only detect them, but we cannot recover them, right? So, general way of solving this is to remove those records. That will be best. Now, artifacts are systematic problems that can be corrected, right? Which is introduced in cleaning process itself. For example, accidentally converting all dates to wrong time zone, rounding numerical value too aggressively. It can be corrected, but it's harder to find them or detect them. But once detected, it can be corrected. Then let's see two imputation methods. So our mostly used two imputation methods are first mean median imputation, where we replace the missing value with the either the mean of the data set or the median of the dataset. If the dataset is symmetric and have no outliers, we replace it with mean. If dataset is skewed and have too much outliers, then we replace it by median, right? Then second method is k nearest neighbor imputation, which is for a record, we find the most similar k similar neighbors or k similar records, and with the help of that, we impute. If the data is categorical, we take the mode of all the k nearest neighbors. If the data is numerical, we take the average of the majority class, right? So this we can help for generating the numerical data for imputing the categorical data, right? These are two imputation method, and this covers our question 3. Thank you.